Ladies and gentlemen, welcome back to my YouTube channel. If it's your first time, don't forget to subscribe and share the video and give it a thumb if you like the video. So on today's video we are going to talk about cell chemistry. It's according to the way you pronounce it, but that's how I pronounce it. So the question reads: hydrogen gas reacts with oxygen gas to form water according to the reaction. If 10 grams of hydrogen reacts with 50 grams of oxygen and 45 grams of water is actually produced. So the first question, identify the limiting reagent. The second question, calculate the theoretical yield of water. Yes, H2O rather. And the last question, calculate the percentage yield. So now let us go to solutions. So the first thing we are going to write we are going to copy the reaction. So the reaction is like sorry. Okay, let me just write it properly. To give what? Water. Yes, this is water. So let us first balance the reaction. We are going to balance the reaction. Here we have two hydrogen, and here we have two hydrogen. Here we have two oxygen. Here we have one oxygen. So to balance this, we should balance we have to the product. We're supposed to have two oxygen. Yes, since we have two here, so we are going to put two here, and here when you multiply this 2 and 2 times 2 is giving us 4. Yes, thank you from my background friends, they have helped me. So here we are going to put again 2. So the reaction is balanced. Now let us go to the question 1. So question 1, identify the limiting reagent. So for us to identify the limiting reagent, first we are going to calculate the moles. Yes, the moles are the one that will help us to tell the limiting reagent. So we know that what the question is saying, if 10 grams of hydrogen. So we have 10 grams of hydrogen. So for hydrogen we are going to say these are the moles. So let's just say moles of hydrogen. Yes, moles of hydrogen is equal to mass of hydrogen over molar mass of hydrogen, which is equal to mass is 10 grams over the molar mass of hydrogen is when we look on the periodic table, it's 1.01. So since it's 2, we're having 2 here, we are going to multiply it by 2, and we're going to have 2.02. It is going to give us Let me just present my calculator. Divide by 2.02 is giving me 4.95. So let me just say, okay, let me just say something like this. Yes, this is what it is giving me moles. Yes, these are the moles of hydrogen. Let us calculate for oxygen. We are on the same question. For moles for oxygen, we are going to have mass of oxygen over molar mass of oxygen is equal to it's we have it's 50. Yes, 50 grams of oxygen. So it's 50 over so when we go on the periodic table, it's 16. That's the molar mass of oxygen. Now it's 2 we are doing to here, so we are going to multiply it by 2. So that is it's 2. Now I'm not receiving any help from the background. They have stopped helping me. Okay, so here again we divide. So 50 divided by that's 2. Divide by that's 2. It's giving me 1.56. Let me just say 3 moles. Okay, so these are the moles. Now We have balanced this. So to determine the limiting reagent, we just what? We just divide the moles of each species involved in the reaction by its what coefficient, that is in what in the reaction. So for oxygen the coefficient is what 2. The coefficient for this is for hydrogen, the coefficient is what 2. For what? For oxygen the coefficient is what 1. Yes, it's 1 here. That's why we don't even write it. So what we are going to do is what to determine the what the moles that were involved, the one which is going to have the smallest number is going to be what the limiting reagent. Yes. So we start for what? For hydrogen we have what 4.95 moles divided by its coefficient is what 2, is going to give us what 4.95 divided by what 2 is giving me 2.4, let me say 8 moles, 2.48 moles. Then for oxygen the coefficient is 1. We are having what here, it's 1.563 over 1. It's going to give us the same moles. So according to what we have here, which one is more? You can easily tell that what the moles for oxygen we are small. It was what the small number. So oxygen was what the limiting what. So you can say oxygen is what the limiting reagent. Yes, oxygen is the limiting reagent. Okay, now we proceed to the second question. The second question requires that as what? Say calculate the theoretical yield. Yes. So we are calculating the theoretical yield. So to calculate the theoretical yield of what? Of oxygen, of what? Of water. So we are going to use the moles of what? Of the limiting reagent. Don't use the moles that you have divided by the coefficients, because these they are just telling you which one is the limiting reagent. Here now, what we are going to do is we are going to use the actual moles that we calculated. Yes. So what we are going to, since this is the oxygen is the limiting reagent, we are going to use the moles of what? Oxygen. Yes. So we are going to use more ratios. Here we are going to use more ratios. So since we have what? So let me just write again the balanced reaction. Okay. So we know the moles of what? Of oxygen. The moles of oxygen is what? 1.563 moles. And we want the moles of what? Of this. So we are going to use what? The mole ratios here. We can just use the mole ratios. Here we have 1, here we have 2. So we can just say 1 over 2 is equal to what? Here we know that it's what? 1.563 over x. We just cross multiply here. This give us x is equal to what? X will be equal to 2 times 1.563. It's giving me 3.126 moles. Yes, so these are the moles of what? These are the moles of what? Of water. Now, since we've calculated the moles, we can now calculate the what? The mass. That's what we want to calculate. Yes. So for us to calculate this mass, we are going to use our formula. Mole is equal to mass over molar mass. When you cross multiply, we're going to say mass is equal to number of moles times molar mass. Yes. We use Mr. to denote what? To denote molar mass. So after there, we have calculated the number of moles. The number of moles is 0.126 times what? The molar mass. Yes, now the molar mass of what? Of water. The molar mass. Yes, so the molar mass we are going to get to add 16 plus what? 2.02. Yes, when the periodic table, we just add the molar mass. It's 2.02 because you are having 2 hydrogen here. So we are going to have 18.02. Yes, something like that. So times 1.2. Yes, and it's giving me what? It's giving me 56.33. Yes, grams. That's what I've calculated. Yes. Then we go to calculate the percentage yields. That is another question. Calculate the percentage yields. So calculate the percentage yield. We know that percentage yield. So let us. This is what the third question and the last question. So percentage yield is equal to what? Percentage yield is equal to what? Actual over your rate score times 100. Yes, that's how we calculate it. And the actual we have been given in the equation in the question. If the question reads again, if 10 grams of hydrogen gas reacts with 50 grams of oxygen gas and 45 grams of water is actually produced. So 45 grams is actually produced. So that is our actual mass. So we are going to put it here. 45 grams over what we have obtained. What have you calculated? We have calculated the what? 56 point what? 3 times 100. Then we just say 45 divided by our answer times 100. My answer here, my calculator is giving me 79.8856. So this is just going to round it off with 79 point. Let us just say 9. Thank you for watching, and this was our question. If you have any question, you can drop it in the comment section so that we try to tackle it.